Welcome everybody to the Kubernetes Phenomenon webinar. Really excited to have all of you on. It's exciting to be here also with Justin Garrison. Welcome, Justin.
Hey, Ben.
And I want to give Justin a more proper introduction in just a second, but there's a couple of housekeeping items that I just want to go through. You know, as you guys are all, I can see the count just dialing up right now. It's exciting to see all of you guys on. So a couple of things. One is that there will be a recording of this later. So if you want to take time later and just listen to everything Justin has to say 2 or 3 times more in the privacy of your own home, you'll be able to do that. We'll send that out later and you can share that out. And also, as you're coming on, ask questions. Don't wait to the end. There's a Q&A functionality at the bottom of your Zoom screen. Take advantage of that. I'll be looking at those questions as we go, and I will answer those questions. And we'll talk a little bit more in a second about Justin's book. But if you remember, for all of those of you who are attending, we're actually going to have a drawing for 20 signed books, and that's your authentic signature, right, Justin?
Sure is.
I saw the picture to prove it.
Yeah.
So we're going to be giving out 20 of those. We'll be reaching out to you guys after the webinar to let you know if you won. So, now to give you a more proper introduction, Justin, it was really exciting working with you. I think you've had a great, history in the open source community, particularly being one of those elusive site reliability engineers. We can maybe talk a little bit more what that actually means, but I think it's, you've been, a big part of the Kubernetes community. Now you're at Disney Streaming Services. And, particularly we were talking about, you're also an author. We have that on the webinar page. You guys should have all seen that, but cloud native infrastructure, patterns for scalable infrastructure and applications in dynamic environments. That sounds very complicated, but I think it's a really good book. I actually took a look at it myself, and I suggest you guys check it out, whether or not you win the book. But Justin, it's good to have you on today. And I want to start off with you tell us just a little bit more about your background. I mean, how did you get into site reliability engineering and end up, kind of in this space?
This is a short webinar, so I can't really go into everything. But essentially,
I expect you to start at birth, but I'll keep you in space.
Mostly, I know a lot of people this way. Like they scratch an itch, right? It's like I wanted to learn something. I, was a poor kid in college and learned this Linux thing, and then got into not only the community around Linux, but also the problems it solved for me. And saying like, oh, I need to type a paper, I need to do these things, and I didn't have money for Windows or new computers or anything. So just kind of learned through that and figuring out how to configure my X session 100 times landed me in these places where like, hey, you're a sysadmin now because you know how the command line works. And so doing that, became sysadmin, and it kind of grew from there as far as just not only in the open source communities and understanding where the industry was going and some new tools and how people were using them, but then being able to bring that back and apply that to what I was doing day to day and how that actually impacted the companies I worked for and help them reach their goals.
Yeah, I know that makes a lot of sense. You still have people ask you to fix their computers, or that's what all my wife's friends ask me, is to fix their computer.
Right. I can't fix one, but if you have 1,000 of them, then
you automate it. That's right. So the reason why we're here today is really to talk about Kubernetes. And one of the reasons why we really wanted to spend time with you, Justin, is that you've been in that community. You really know it more at the grassroots level. So talking a little bit about I at least in my career, I've seen the growth of a lot of different technologies. I've been around for a while. This is the fastest growing technology movement around Kubernetes that I've ever seen. Why do you think that is? I mean, what is it that is really driving the movement here?
I mean, I think it's a lot of timing has to do with it, I'd say, in a lot of regards, where Kubernetes isn't the first system to manage containers. It's not the earliest thing. It's not the easiest thing to run, but it solved problems when people had the problems, right? You can too early is also wrong in some cases, where like Mesos is great. It's a fantastic system. It's been around for a long time. It was born out of this environment where in education circles and people had these scale and problems early on, but it might have been early for a lot of companies. And now people are reaching some of those problems and understanding, oh, I also have these problems. So now what is the thing that I should be doing? And Kubernetes kind of balanced that as far as timing wise when it came out, but also flexibility in what you can do with it, how you can extend it, and the core fundamentals of making these, extensions to Kubernetes and simple controllers that you can write in any language. These were all things that Kubernetes really did well, as well as just putting it under a neutral foundation to be able to maintain it, and multiple companies can contribute, because that's large companies have licensing restrictions and lawyers and things that also prevent them from being able to contribute to these communities. And that was a big thing that when Google, gave it over to the CNCF, that was the main goal, was get more companies involved.
Oh, that is really interesting. I mean, because that's an important point there too. I mean, this is coming out of the Google ecosystem. They built this off of a system they had internally, where this isn't just a new project that has started up. I mean, in some sense, it's been battle tested, right?
Yeah, and it's not even Google's first open source container. I mean, I don't know if you remember, let me containerize that for you, was like,
oh, I don't.
Made before Kubernetes, which wasn't running Docker, which wasn't taking some of these extra tools from the industry, and Google was pushing out more of the how Borg was doing it, and they understood internally, like, okay, well, this may not be the right solution, because people are already adopting Docker and the Docker container as their actual artifact that they're pushing around. So how can we manage those instead of these containers that Borg uses, or internally, their other container definition?
Oh, that's interesting. And one question I have too is I remember when I was kind of in a transition in my career, I remember running into a containerization company that shall remain nameless. And this was a while ago, and it let's just say it failed. But as you say, it's like partly the timing here. Containers in general and Kubernetes in particular. What is it about the timing right now? Is it because of microservices? I mean, what do you think why is the timing so right? And what is it about containers from your perspective as a site reliability engineer? What is so attractive to you about kind of containerization?
It solves the people organization aspects inside of a company, right? I mean, originally we had these large servers that everyone would just SSH into and install their stuff. And that didn't work. I mean, it worked fine for, let's say I have a static binary. Everyone can just run their binary, and every person in the organization can run off one machine. But later on, like we have, dynamically linked libraries, and like, oh, well, you changed the library that I needed on my application. So we have to split those into two servers now. And this compounds and grows and grows and grows. The more people we have, the more isolation we need to have from everyone else, from the applications, from dependencies, and allowing people to self-organize into teams and also self-drive, like whatever it is they need, they can compartmentalize that into this, binary essentially of a container, and then ship that, and then say, okay, run this package of all of my stuff that I need. And so really it's solving the organization problem of independent teams being able to run something on some compute resource of some sort.
That makes a lot of sense, because I think sometimes the whole cultural aspects get lost. I mean, these are people doing this, and I think that's interesting how you say that, because I mean, some sense is that now these kind of cross-functional development teams are owning their code from cradle to grave, right? And so it seems like containers is what I'm hearing you say, is that containers is actually a better way to manage that. If you're really going to own it end to end, it's actually easier to own it in that small compact component. Does that sound right?
If you're working with any other teams, yeah, absolutely. Yeah. I mean, if you're a small startup and you're 5 people, you have one thing, like don't go all in on Kubernetes. Like, just install your one monolith and everyone can develop in that, because it's not a people problem. Right. And so once you grow into more teams or a big organization or more complex applications, that's where you really need to be able to isolate independent components, but also scale those independent components and say, oh, well, our front end needs 1,000 instances, but this little piece over here only needs 2. And that's fine, because you can independently scale those things.
Yeah. No, that makes a lot of sense. And, one thing in particular with your experience, and I mean, you're in a larger company now with Disney, is, one of the things I've heard from some of the people I've talked to is that one of the things driving Kubernetes adoption from them is also that it seems to make the transition to cloud and actually, even multi-cloud easier? I mean, what's your perception of that? I mean, because one sense, like being able to handle the multiple teams together, that makes a lot of sense, and being able to own the code, cradle to grave. But do you see, like, in your experience, that it's actually helping people make that transition to cloud, through the containerization framework? Does that make sense?
I think as more clouds have adopted Kubernetes, it's definitely
Yeah.
brought an uptick, because it is this standard API across all cloud environments, where originally the standard API was a VM, essentially, like, right, you give it a VM image and then they run that thing. But at that point, okay, well, did you pick, I hope you didn't pick Amazon Linux and want to go over to Google, or I hope you didn't pick, like maybe you have Red Hat, but you want Debian somewhere else. And all your tools change at that point. As far as, I mean, config management is supposed to solve some of that by abstracting away,
right,
management things, but it is still some sort of lock-in, where containers care about the Linux kernel. They care about a lower level of, where do I need to run? I care about my, my Docker runtime or whatever container runtime and a Linux kernel, and everything else I bring with me. And so I don't really care. Yeah. We see that great in minimal containerized OSs. I mean, Core OS was a pioneer here, where there was no package manager. Everything is a container. And that drove a lot of demands. And how do you get your binary to those cloud environments? And clouds have, obviously, every major cloud has Kubernetes, hosted Kubernetes, and there are installers for all these hosted cloud environments. So you can run Kubernetes in those environments, but you can't. It was maybe harder to run something like VMware. It might have been impossible, because nested virtualization and everything else.
That makes a lot of sense, and that is actually one thing that has really impressed me with the adoption of Kubernetes, is how quickly the cloud, the big cloud platforms actually just embraced it, and really just went, whereas I think you saw that with some other technology changes, they didn't necessarily embrace it right away, but they seem to have all embraced it. Obviously Google embraced it, but Amazon and Azure have also game for a lot of people that want to do it.
And it's not the only containerized platform for these cloud providers, right? I mean, like, Amazon has ECS and Google has App Engine. And so they had other ways to run some sort of containerized thing, but it was to a single cloud environment. Like, you couldn't do App Engine on-prem, and I couldn't do ECS in Google. And so having a more standardized API across all the cloud providers is definitely a win for users, because they can adopt that and say, well, if I don't want to be there, yes, it's going to be work to pull that on-prem or switch clouds or run in multiple clouds, but it's possible.
Yeah. Well, and one of the questions too, I mean, you kind of addressed this, but one of the things, coming from your background, you said about automating a lot of systems. I mean, with config management, one of the reasons why you did that was for patching and upgrading. When you think about that in containerized environment, has that become harder or easier? So when you're trying to update code, you're trying to update patches, both security perspective and code perspective, is that easier in a Kubernetes environment, or is that now harder?
There are aspects that are easier, where I can now do my patching and scanning at build time, which is a big win, where it was hard to do that, because config management was usually long running, Linux systems or Windows systems that were up forever. And I once it was installed, then I had to go back and scan and make sure things were correct. With containers, I can scan that before the image goes out. But the hard part is, in containerized environments, those endpoints are much more ephemeral, and so I can't do the, where did that thing go that was had a problem, because I know there's a library out there that's SSH is bad or something, like those sorts of things you can't do, but you can more quickly push out changes, which makes the actual remediation a lot faster. Where Linux hosts that are there for a long time, you may not know everything that's on it. You may not know every service and endpoints. That becomes really difficult and becomes more of a coordination between people. Containers, scan it at build time or replace it in while it's running.
Yeah, that makes a lot of sense. And kind of transitioning to something related to that. I mean, in your experience, most of what you said, so far has been highly positive. It sounds like it's kind of obvious to adopt Kubernetes, and I've heard a lot of positive things myself. But what do you think are the biggest obstacles? Because obviously not. The adoption curve has been huge, but it's not like everybody is moving over to Kubernetes tomorrow. It's still a process. What do you think are the biggest challenges to actually adopting Kubernetes?
There's a big learning curve for a lot of people. It's not only hard to understand the abstractions and how the system works, but it's also almost impossible to keep up, right? No single person knows all of Kubernetes. And if they did today, they won't tomorrow because it changes that fast. And so people learn Kubernetes, or they learn a version of Kubernetes, and then the next release, most of the things they know is out of date. So that's hard at the people side of learning these things, but then like understanding what pieces you actually need to understand. The other side of it is being able to trust a system is really hard for people to adopt, as far as we all kind of trust cron on a Linux system because it's gained our trust over decades. And
right.
That's fun because, that cron that I set to run every Monday is still going strong, but the system has bugs, and I may not be able to trust everything that it does, and it may not solve all my problems for how I need to use it. And so there's the other side of it. How do I need to change what I'm deploying and how I'm using things versus here's my bash script cron, please run this every day.
Yeah, no, that makes a lot of sense, because you're always going to be balancing that. And you talk to me a little bit about that. Is that, what do you think? I mean, we've talked about a lot of to some degree, the right reasons to adopt Kubernetes. I mean, if you're wanting to scale, if you're, it helps deal with the, interactions between different teams, because they can use different code bases, they can, but have really killer interactions with each other. What do you think are the wrong reasons to adopt Kubernetes? Because I mean, it's not, with something like this, there's a tendency to sometimes apply it to everything where it's not appropriate. So what have you seen are some of the wrong reasons to adopt Kubernetes?
I mean, first of all, just say you don't need Kubernetes to have a successful website, right? Like, that's just not a requirement. And some people, it's kind of an industry thing to think like, well, you're not running Kubernetes. Like, how are you going to scale? How are you going to do these things? Like, well, we've solved these problems a long time ago. There's other ways to do this stuff. And there's other, options out there besides just Kubernetes. Kubernetes is obviously the, gold standard in a lot of cases, but it's not requirements. And second, I actually heard this, saw this quote yesterday where if you have a Kubernetes strategy, you've already lost, because your strategy shouldn't be Kubernetes. Your strategy should be business. Like, how does your business work? How does your business make money? And Kubernetes might be an implementation detail, the same way that Linux or using Go or these other things are implementation details of, hey, well, we want to solve this business problem. Let's find the checklist for that. But the strategy should be the business problem, how the business makes money, and how what you run solves that problem. Because everything else is just overhead. If the business, didn't need computers and didn't need people to do that, like, guess what? The business would make a lot more money, and that's good for business, right? In most cases, like, people are employed, they get paid for their time to make the business money. And understanding where the balance is of how much time are you going to spend learning and building Kubernetes? What business problems does that solve? Is a big thing that I feel like I've learned a lot in the past, few years, and a lot of people are coming around to understanding, okay, the thing I wrote or the thing I run, how does that actually impact the business or the business goals or that strategy? And that's really a piece that people miss a lot.
Yeah, I think it's really interesting how you're talking about that, Justin, because, one thing I've seen before, particularly early on in my career, which was well before Kubernetes, was that, a lot of times you would see, the I would call it the trope, or the running joke was that a CIO would read something in CIO magazine and be like, I want that technology. And then, tell the tech people to go do it. And they're like, what the heck is going on? But I think in this instance, particularly when you talk about the cultural thing, this a lot of times is a grassroots, phenomenon. And so, I think that's a really important point you're making, is that as a technologist and as an engineer, you want to adopt the newest, coolest stuff, but if you want to be successful, particularly in a larger company, you need to be able to draw that line between, I want to do this, but this is how it's actually going to make things better for the company, is how it's going to, get us to market faster, is how it's going to, save money, whatever it is. Being able to make that argument, it doesn't always come naturally. So I think that's a really good point for people to keep in mind. And one thing is actually a real interesting question before I move on to something else came up. I mean, do you, one of the questions here is do you see a divergence between open Kubernetes and the, cloud implementations like, GKA, EKS, AKS. Do you feel like they're staying reasonably close, or there's any divergence that concerns you?
I mean, there's reason for divergence in a lot of those cases where, the open source Kubernetes doesn't need Amazon's, IAM integrated deeply, because most people, that are running open source maybe aren't running in Amazon, so they don't need the IAM permissions of Amazon. And so there are, cloud specific things that people are putting into Kubernetes.
Yeah.
And I think that's fine, because that makes the user experience, the operator experience, much better to integrate into that ecosystem, because the goal isn't to be able to do everything yourself. The goal is to be able to, again, what business problems is solving. And if security is a problem, you're going to need some IAM permissions to restrict, container and, what access they have inside of the cloud environment. So that's fine to have some divergence in those specific environments. Or a lot of things are coming out that are on top of Kubernetes, where it's the actual PaaS layer that you want on top of this infrastructure layer. And that's also good, because Kubernetes, again, the core principles of Kubernetes allowed for those extensions, allowed for those hooks to extend it. And that's, again, one of the big things in Nomad from HashiCorp is an amazing product and solves a very specific problem with containers of fast job scheduling at huge scale. And if I need a job to land fast, Nomad is going to beat Kubernetes every day. And the other extensions that I can add into Nomad that I get in Kubernetes. So what's my business problem? If my business problem is schedule a bunch of jobs as fast as possible and get those containers running the fastest possible that they can, Nomad's probably going to win if that's my benchmark. If it's I need these other things of security and ingress controllers and these other on top CRDs that people are building into Kubernetes, that's probably where if I measure Kubernetes against that, that's obviously
that makes less. I mean, it's back to what you said before. I mean, you really want to think about the use case and one thing I've also seen, and I think you are seeing that Kubernetes is also being used for a lot of these as a way to, because in some sense the growth of the Kubernetes adoption has meant that Kubernetes is actually also being integrated with a lot of different tools that you wouldn't necessarily thought off the top of your head. A lot of these. This
week is VMworld, right? And VMware just announced vSphere is now integrated with Kubernetes. You can run it'll run Kubernetes on top of vSphere, and traditionally that is I need a VM or I need storage platform, and they understand that people are trying to solve problems faster with a Kubernetes API, with the abstractions that Kubernetes brings, not the abstraction of a pretend machine that runs in software, right? I don't care about servers anymore. I care about applications. And that's where, VMware this week announced that they're shifting over to that, because that's where business is finding more value.
Yeah, no, that's really interesting. One thing I've also seen in my experience too is that, obviously, Google is pretty committed to being part of the Kubernetes community, but I've also seen, Amazon and Microsoft not only being, involved in the, their integrated environments on their cloud environments, but I've seen them actually be involved in the on-premise installations of it, which I think is, again, very different than what you would have seen a few years ago, where they've, at first it was, I had to do a double take. It's like, you're doing what? But, they're actually really involved in that on-premise community. But to your point, it helps actually, because there's a question about migrating on-premise Kubernetes. I think part of the thing is that the cloud vendors realize that they need to make that easy, because they need to make it easy to transition on-premise Kubernetes to the cloud. They seem to be somewhat committed to that right now.
There's multiple ways to transition that, right? I mean, some people are, here's my Kubernetes on-prem, let me make it look like the one in the cloud, and I can just send my stuff there. The other way is things like Anthos from Google or I forget the Amazon one, where they actually send you hardware to run in your data center, and then you run it on-prem. Literally, here you go, cloud provider gives me hardware, and then I run that in my data center. I run the actual GKE or EKS on-prem, and I don't have to, I'm not standing it up and monitoring the entire, running the entire thing from scratch. I can just use the actual one that they provide and run it on-prem.
It reminds me of when I was at AWS reInvent last year, and there was it was one of those their storage devices they have now, but it was in this big glass case at the back of the hall, and you could go, and they were selling hardware. And I'm like, okay, the world it's just a big circle. We're coming right back to what we used to be doing. So but again, their primary objective is to get people on their platform, and they're going to do what they need to do to make that transition easy. So, want to make a little bit of a transition. I was kind of joking about it a little bit in the beginning, but, as a site reliability engineer, that concept is not, that is very associated with Kubernetes. So, I mean, in your experience, one of the questions people would have is doing site reliability engineering, particularly as, Google kind of defines it, is that a necessary step to adopting Kubernetes, or is it just, how do you feel that connects, and how important is it?
Mostly, I feel like it's just a cultural thing. I mean, both these terms came up around the same time. I mean, nothing in the SRE book that Google describes ties SRE to running containers. It is a people organization function that they definition that they set up, that here's how we solve this problem of managing these people to manage these applications. Just like DevOps is typically tied to config management. Mm-hmm. There's nothing specific that's like a DevOps engineer is like only doing config management. It just so happened that both of those things happen culturally around the same time. So if you're a sysadmin, you manage a Linux box, but if you're a DevOps engineer, you do config management. If you're an SRE, you do containers. I mean, that's not actually how this works. That's just culturally how people learned about these terms. And it's kind of made them sticky in a lot of people's minds. But if you're a sysadmin and you're running Kubernetes, that's fine. Like there's nothing like, you should be, if you can successfully use the tools, like there's nothing that means your title has to change. But in a lot of cases, like there's marketing around it, there's recruiting around it. So I understand that like the industry changes with these terms because the industry tries to stay relevant. But I mean, I still consider myself just a sysadmin. My title has changed over the years, but it's not necessarily like I don't do things different. I just learn a tool. I adopt a tool, and then I figure out like how that fits into the rest of my.
They don't check your ID before you can download Kubernetes. Sorry, sir, that is the wrong title. Absolutely. I mean, because it's one of the things that is kind of the truthism is that I feel like I've been doing this since the boom, and bust. Personally, but it's really the same fundamental problems. We're doing different technology and different scale, but funnily, it's still a lot of the same skill sets. And I think you're absolutely right, because I was doing DevOps before we called it DevOps. It was still the same stuff, right? Yeah. So making a bit of a transition now to talking about. So you decided to run Kubernetes. You got it up and running. What do you think are the things that people need to really think about now that you've got it running? You've actually got applications, containers running on Kubernetes, wherever that is. What are the key things you need to think about? I mean, in terms of, monitoring it, keeping it healthy. I mean, what are the things that, now with your experience that you've run into that you think people should think about?
I mean, for me, the biggest hurdle, like being successful with Kubernetes, trust that Kubernetes is doing the right thing. And a lot of times I gain that trust by not only over time of just letting it run, but also being able to observe it, being able to understand what's happening. These environments are so complex that like not a single person is a computer and is like, I have to go to sleep, I have to eat, I have to do other things just to maintain my life, that like I can't understand like, oh, is that ingress port up right now? Oh, is that container scale at this? Is this image version this? Like people don't do that anymore. We used to on Linux systems because it was a static environment. In these dynamic environments, we have to trust this system is doing the right thing. And so in a lot of cases, for me, it's just being able to observe what's going on in Kubernetes in a way that makes sense to me. And sometimes that's dashboards, sometimes that's command line tools, sometimes that's just log output. People understand these things differently. And then being able to actually like ask questions and troubleshoot it gains a lot of trust. If I can actually say, okay, I have a pod that has a crash loopback, like what is that doing? Like why, what happened to that deployment and how do I debug that? And in the old Linux days, or in a lot of cases, I can go on a box and I can S-trace something and I can understand like, oh, here's the file descriptor that it's stuck on and I can't get to that. I can't open that file. So that's probably where my problem is. And in doing that in Kubernetes is a lot harder with distributed applications. Like there's no strace for a distributed application, right? I mean,
Right.
distributed tracing is solving some of that problem for HTTP requests, but not necessarily like deep down into the kernel of like, okay, well, where is this actually stuck? And how do you ask those questions? And for me, it's all about trusting the system and being able to not only just like vaguely under like high level overview of what's going on, but also ask those questions of, okay, something happened, why? And that's really, I mean, observability practices have come out of really, how do you understand these systems now because they are so complex, and how do you observe them and ask questions, and something that's an unknown, how do you figure that out to then understand it?
Yeah, it talked to me a little bit about the term there, because I mean, one thing I really noticed, and I feel like there was I think it was maybe Monterama a couple years ago, I can't remember, but there was kind of it felt like there was a sea change from like, we're not talking about monitoring now, we're talking about observability, and it's first like, what the heck does that mean? But I've heard the term before, but the context it was being used. So in your sense, number one, why do you think the terminology's changed, and what does observability you think actually mean? As all marketing and fluff aside, what does it really mean, you think, for you as an SRE?
Yeah, monitoring again is checking things in mostly like a static environment. It's not necessarily asking questions. It's a set of knowns that I want to validate. And so historically, like if you're in a data center, you have like SNMP scans, right? SNMPs goes and scans all these endpoints. You have a text file or something, a config file that says what the IP addresses are, what they should have running for them, like a temperature of something or whatever it is. You do an SNMP scan, you monitor those things, you validate the knowns. And so you're like, I know that this temperature should be between this threshold. And if it goes beyond that threshold, send me an alert. And that's a monitor, because I can validate the thing that I know is true. And observability is again, asking those questions of things that I don't necessarily know why it's going on. I can understand things more by asking questions. And if you're in Kubernetes, like you don't want to run SNMP inside of all your containers and then try to find those endpoints and do SNMP scans of containers, right?
Yeah.
Like that's not necessarily the right track of like monitoring these things. You want to be able to understand what happened, because things change so frequently, and it's not a static thing of, I know this endpoint should have this. It's, okay, what happened? Like, why is this thing different? And why is something not working? And that's the observability piece of being able to ask those questions of things that I don't understand yet.
Yeah, well, that makes sense. And my undergrad and grad was in in physics, and it's always like I kind of come back to where the term even originally came from was, do you, in what you can observe, can you understand the state of the system? And I mean, like you're saying, I think sometimes in the older world of servers and Linux, I've been in that world myself, we sometimes took it for granted that you just kind of get in there and you screw around until you figure it out. And to your point, what I hear you saying is that it's just it's a different problem in this world of, sometimes when I look at, I don't know if this analogy makes sense to you, but when I look at, Kubernetes in particular, but also this containerization, more broadly, it's almost organic. It's there's so much change, and it shifts constantly that you can't apply the same methodology you might have used with a Linux box, or with 100 Linux boxes over here with thousands of containers. I mean, does that ring true, that kind of that sense to you?
Yeah, I mean, first of all, air high five, because I also have a physics degree, so that's awesome. But yeah, it is. People don't scale, and people are the ones that actually are smart in these situations. They're the ones that actually understand the things and tie the technical thing that's happening to what the business need is. And that's the person in the middle is the glue that does that. And so you need to be able to understand the thing that's running and how that solves your problem. And I can't do that across 1,000 systems with S-trays. I mean, I could, but I probably wouldn't understand it necessarily. Like, you need to be able to ask better questions of these systems, and the platforms have evolved to allow us to ask better questions around like what's globally going on. Not like I can start broad and dig into one specific area and then see if that's the fix. My SSL library is bad. I have to like broadly say, okay, guess what? Like, I'm getting TLS errors at the endpoints. How do I then like figure out like, okay, why? And narrow that down to, okay, this box has this problem because of this error. Oh, look, these other 50 boxes have that same problem. Oh, here's the package that was bad or something. And so, yeah, you have to the platforms allow us to start more broadly to ask those questions and narrow it down to find the fix. Whereas the other way, it was always, oh, well, host 123 is having, problems. Let me go SSH into it, and I can dig around on the file system or, init system to find the problem. And that doesn't scale.
Yeah. Yeah. That makes a lot of sense. One of the things I've noticed too is I think that the way that Google designed, the system and, how they use it, they put some of those higher order concepts in there, like, services and namespaces and things that kind of allow you to step back a little bit and not just be so focused on the individual pod, not get lost in the, forget the forest for all the trees, right? Or, be focusing a little bit of bark on one tree and that's it, you get lost in that. So I think this is great, and we're actually getting a lot of great questions coming in. I encourage you, keep asking the questions, and I'll try to get through as many as I can. If we don't get through them, we'll follow up with you. So one really great question here that I thought was interesting. So, I hear about Istio in the context of Kubernetes, and it comes up a lot, in terms of like this the function around mesh services. So talk to me a little bit about how you see that intersecting with what we're talking about with Kubernetes.
Yeah, just like Kubernetes, don't use it if you don't have to. If you don't have a business need, or if you don't have a situation where I know I need this thing, don't bring it in for resume-driven development. It's just not a great look for the rest of the business, and it's going to add a lot of overhead and a lot of just things to maintain. And again, people don't scale to maintain these things forever. But Istio is solving a problem of, the main problem I see it solving is bringing the network layer closer to the application, where I can, if everything is a HTTP request or a gRPC request, I can then do things intelligently based on that without needing to have access to a switch or a router or even a load balancer necessarily that's like centralized in my environments. I can make those policies and rules closer to the application. And if it's your development team doing that, great. Or the operations team can actually do that with the development team, and they don't actually need to interact so much, where I don't need to build in that functionality into my application. And it's much more flexible for an operations person to be able to say, oh, guess what? We have failures in this region or in this cluster. We need to reroute that traffic. And historically, those changes take a long time at a network layer, whether, DNS TTLs don't always work great. And so there are things that we've used historically that, have solved the problems, but a lot of times, because the environment's more dynamic, we need to be able to move faster, and we need to have a better understanding, or at least closer to the application layer understanding of what's going on. So if we move that logic into layer 7 of the network stack, where I'm actually understanding the HTTP request, then I can route based on a path or a host name or something and send that to the right place. And also it adds a bunch of other things as far as security for, mutual TLS authentication. Those sorts of things just kind of can come with it. Not necessary initially, but if you do need to switch your traffic or move to different versions or do some better canary deployments, those sorts of things, those are business needs that often happen. And the way that the industry is kind of standardized on that, and under Kubernetes at least, is with things like Istio and Linkerd at this network proxy layer. Historically, it's been done in application libraries, right? Like people had libraries they'd import into their system, but if I need to change the library, every application needs to recompile and redeploy before I can actually use that thing. As a external proxy to the application, you can actually have that managed by separate teams and be okay, because they can both move at the velocity they need to. And it's not necessarily, oh, well, I'm on a code freeze, so I can't change that. I can't change my application. Oh, but guess what? My sidecar proxy, I need to push out some new version of it for some critical. There was a CVE for Envoy not long ago, right? Like how do you deploy those things together? And hopefully they're not coupled for teams or anything, so you can just redeploy the thing. The new Envoy gets pulled in, and your security fixes are in place, and any other major features or bug fixes are there.
That I think that's a great explanation. Honestly, you actually connected some dots for me. So thanks for walking through that. A couple more questions here. So one is somebody was asking about storage for Kubernetes, and it's actually something I wondered about myself. So when you're thinking about that, typically when you're thinking server-based systems, storage is the first thing you think about. you have, because you have to connect to disks or, attach storage or whatever it is. From the Kubernetes perspective, how do you have to change your thinking in terms of where you store your data? And I mean, assuming you have to adjust your thinking somewhat, because you're not storing it in the container, obviously. So how are you thinking about that?
Yeah, I mean, there's been a lot of great work in the Kubernetes interfaces for storage, for providers that are providing that information. Like if I'm in Amazon, I can get EBS. If I'm on-prem, I can do things like OpenEBS or Rook, or there's a lot of projects out there that are doing this and bringing storage into that more dynamic environment, which is essentially, bring my container in, bring some storage in, start the application. Which is great because it solves problems for people. My usual suggestion to people is, if you can get away with having a cluster that has no applications with state, do it. Absolutely. If you can demand that in a cluster and say, hey, guess what? Like, you don't get storage here, you can make things so much easier to upgrade your Kubernetes version and to move applications and to move regions and to do these things, because that storage has, the data gravity around it. It takes more time. There's a lot of things, a lot of bugs that get introduced when you say, I need stateful stuff on a file system. Once POSIX is in the mix, it's a hard drug to break. And people are going to attach to that, well, I have this file system now, so I can do these things. If you can say hey, you can keep state in this database or in this object store or in these other things that are HTTP requests or some sort of network, if it's, MySQL or even RDS or something, like use those as external storage. And if you can, as much as possible, don't bring storage into the cluster, it'll make a lot of things easier. I understand not everyone can do that, but I have had the benefit of having clusters that were 100% no storage allowed to the containers. And it's been phenomenal for being able to update those clusters and move them forward and get features and, do things that I wouldn't traditionally be able to do if I had state in that environment. So it does solve a business need, especially for legacy applications. There are options that bring that, storage in place. Some systems are better than others at allowing that to happen. Some, if people are running databases and, they're definitely be careful around you're not necessarily running on a local SSD necessarily. So you need to, be mindful of your latency, of IOPS, all that kind of stuff comes into play, and there's a lot more testing involved. But if you can, as much as possible, the newer applications I see are using only external storage, and they're designed with that sort of mindset of, this call might take a while. How do I adjust for that? And how do I make sure that I have a local cache, or I can do some things that I'm not keeping long-term state, but I can be more resilient for network outages or something else going down.
I think that's a really good explanation, and it gets back to what you said before. You have to rethink how you approach some of these things, and it's important to really think through what you're trying to accomplish. So one last question for you, and then I'll wrap it up. So great question here. You want to find out more about Kubernetes. How do you get started? I mean, is there a particular distro, or what's the right way to start out?
I truly feel bad for people that are getting started today. I had the benefit of starting, 4 or 5 years ago. Even the Slack channel had, only 1,000 people in it at the time. Now, I mean, last I looked, it was 40,000 people in Slack. It is really crazy. There is a lot of good resources out there. It depends on, I guess, what you're looking for as far as are you developing applications on top of it? Are you running it? Are you extending it? There's all different areas that you can get involved. The Kubernetes community is still really great as far as just being welcoming to anyone coming in to learning things. There's a lot of good resources. My first contribution to Kubernetes was in the docs. I made Kubernetes docs contributions and pull requests. It's hey, guess what? I didn't understand this piece, and I cleared it up. Here you go. Please have a pull request. So the docs are a good place to start, but also look at just the general. There's a Kubernetes community GitHub repo that breaks it down into SIGs, the interest groups, which are focused on specific areas. So if you want to be part of the storage SIG, you can go there. They have a weekly call. They have mailing lists. They have forums. Those are good places to start at a specific area, and then kind of broaden your scope from there. I wouldn't try to just take the fire hose of Kubernetes and say, okay, I want to learn it all right now. There are, if you want to stand it up, I usually recommend people like start with just a hosted version, go to GKE. You can run GKE I used to do it at my lunch breaks, a couple hours, I would run GKE, and it literally would cost me, I think it was like 4 cents. And so I could run it for a couple hours, 3 nodes, and I could spin some stuff up. I could understand, I could like dig into it and say, okay, where did this go? Why did this happen? And I could ask some of those questions at a very basic, no application layer, just understanding Kubernetes. And again, it was, less than $1 for a month of doing that at lunch breaks. And so those are places to like ask your own questions and understand things at a smaller level, and then reach out to the community and get involved in, in the SIGs or in Slack, or there's Stack Overflow has tags for it. There's a lot of places for like, find the people that are doing the thing you want to do and go talk to them. The community is super welcoming. I mean, the biggest problem Kubernetes has ever solved for me was making friends in my 30s. Like, that's full stop. Like, and it's just like amazing because like I've made such good friends in this community over the past few years that it's like we are great friends. I mean, my co-author Chris, like we never knew each other before writing that book, but we both were in Kubernetes community, and we got connected together, and then now she and I are great friends, and this is amazing that like this community can foster this sort of welcoming environments and help people like get started, because it is a big thing to take on if you're just looking at it as, I want to solve this technical problem. This is the behemoth of Kubernetes. How do I do that?
Yeah, I like that. That's a good note to wrap up on, is adopt Kubernetes and make friends. I like that. Well, Justin, this has been great. I think you've done a really good job of walking, through this, and I encourage everybody to check out his book, Cloud Native Infrastructure. Like we said, we'll be handing out 20 of those, but I definitely encourage you to check it out on your own. And just to wrap up here, I'm going to share just a couple things here to round it out. So, it was really exciting to have Justin with us here today. And one of the things that I've been excited about being part of Sumo Logic, as the sponsor here, is that we've been committed to this community for a long time. Before Kubernetes, and we actually use Kubernetes ourselves. And this is kind of practicing what you preach. We running across all around the world. We're early adopters of Docker, and early adopters of Kubernetes, and and also then helping our customers get visibility into those platforms. That's why we wanted support this community, and we're happy to talk to Justin. And one thing I would say is we actually have our conference coming up on the second week of September, starting on the 11th of September. And this is now our third conference, and we actually have a dedicated Kubernetes track. We're really excited to have several of our customers talk about how they've implemented Kubernetes, how the successes they've had and some of the challenges they've had. We're going to have a lot of different information about that. We're actually going to be introducing a Kubernetes certification. So again, as part of our commitment to the community, we've introduced a new certification as part of our larger certification program that will be focused just on helping you get visibility into Kubernetes and get a lot of value out of it. And also, we are going to be having a big announcement around Kubernetes about some new functionality we're going to be releasing that's really just specifically built for people like you that are trying to manage Kubernetes and do it in a way that's actually going to get you where you want to go faster. So I definitely encourage you to come check it out. It's in the Bay Area, but you can also watch the keynote online. So I definitely encourage you to check that out. And then finally, with my big fancy microphone that Justin was making fun of me before, it's part of the reason why I have that is because we have a podcast, and one of the things we love to do to give back to the community is to, with our Masters of Data podcast, I encourage you guys to check that out. We've actually had a lot of really cool guests on there. Not as cool as Justin, but almost as cool. We brought on some people to talk about data science and about how to think about data, and some cool people from Stitch Fix and Samsung and Primer.ai, and just a lot of really interesting people. So I encourage you to check that out. So with that, I just want to thank everybody for coming on. And, once again, Justin, I thank you for taking the time and actually signing those books for us. And we really appreciate you taking your time, and thank you for coming on.
Yeah, thanks very much.